Hello, this is Orlando Castilleja. Today I'm going to guide you through a new tutorial on the use of SolidWorks flow simulation. In this tutorial, we are going to specify a time-dependent study, and we're going to be modeling a cup of tea that is being cooled down. The geometry or the model is going to be composed of both the fluid part and the solid part. In the case of the fluid, we're going to assume that we have water, and the water is at an initial temperature of 87 Celsius degrees. On the other side, the cup, it is made up of a ceramic material. In this case, we're going to be using a typical alumina, and the initial temperature of the alumina, it is going to be 20 Celsius degrees. So what we want to achieve with this tutorial are three main objectives. The first one, it is to show you how you can specify a time-dependent study. Later, we want to show you how you can specify an internal type of analysis. Remember that we can have both internal and external type of analysis. In this case, we're going to review an internal type. And finally, we want to show you how you can specify different initial conditions for different regions or subdomains in a single or within the same model. So the geometry that we are going to be working with, it is going to be something similar to this. We're going to have an inner diameter for the cup equal to 80 millimeters, and we're going to have a thickness for the cup of 5 millimeters. All of the other parameters that we're going to need are represented in this slide. So we're going to be coming back when we need them. So as I was telling you, the initial conditions are going to be for the ceramic material equal to 20 Celsius degrees for the temperature, and for the water is going to be 87. Here I have to modify this, 87 Celsius degrees. Remember that we're going to be using alumina and water. So later we are going to have to define the mesh. This is going to be according to what you need or the computational resources that are available in your computer. So at the end, we are going to be obtaining temperature profiles similar to this. Remember that we are going to be specifying time-dependent type of a study, and we're going to obtain captures at different points of time for the temperature profile. So at the end, we are going to obtain an animation similar to this. But remember that CFD is not all about obtaining temperature profiles or animations. We also want to obtain specific values or specific plots and profiles for the temperature or other parameters. In this case, we are going to help you to obtain this kind of plots in which I'm showing, for example, in this case, the temperature, how the temperature is changing in time for the temperature of the fluid, and how the temperature of the solid is increasing as we progress in time. Okay, so I'm going to be moving to the software, and the first thing that you're going to see when you open SolidWorks is going to be a window similar to this. So you're going to be able to select a part to create a new part, an assembly, or a drawing. So we're going to select a new part in this case. So here we have the main window for SolidWorks, and this is going to be your toolbar, the feature manager design tree, and the main workspace. So I'm going to position here in the design tree, and I'm going to select the top plane. Okay, so when you select the top plane node, you're going to observe that a small box pop-ups here, and I'm going to select a sketch. So I want to start drawing from this sketch, from this plane, I mean. So as you can see in the workspace, the top plane is going to be presented in the main frame of the window. So I'm moving to the sketch menu, and I'm going to select the circle element. I'm going to click here, circle, and I'm going to start drawing the circle from the red lines here, the red arrows. So I'm going to make sure that I highlight this orange point, and I'm going to drag from here in order to draw the circle. So here we have the circle, and now I want to specify what is the actual diameter of the circle. To do this, I'm going to move to Sketch, and I'm going to select a Smart Dimension. So I'm going to select the circle here, the blue circle, and I'm going to locate this label anywhere that is convenient for me. Right? So I'm going to specify that the diameter, it is 80 millimeters. Okay? So you can click OK here. So if you are not working in millimeters, you can change the units that you are working with here in this region of the window. So you can select millimeters, centimeters, meters, or inch, right? So I'm going to be working with millimeters. Okay, I'm going to close that dialog here, and I'm going to select an isometric view. To go to the isometric view, I'm going to view orientation, and I'm going to select isometric. Okay, so what is going to happen next, it is that I want to extrude this circle in order to create the main body of the cup. So I'm going to Features, and I'm going to select the option Extruded Boss Base, right? So the height in this case is going to be 100 millimeters. So 100 millimeters. Okay. If we close this dialog in this way, we're going to obtain a solid body. Okay. But we don't want a solid body. We want a cup that is going to be a hollow body. So I'm going to select Thin Feature in order to create a hollow body. And I'm going to specify a thickness of 5 millimeters. Okay, so there you go. I'm going to click OK, and I'm going to have something like this. Okay, so I need to create the base of this cup, and to do this, I'm going to rotate the body. If you don't have a mouse, you can use your keyboard, the arrows in your keyboard, to rotate this body. Or if you have a mouse, you can rotate it using your scroll wheel. Okay, so I'm going to zoom in here to this region, and I'm going to select this surface. Okay, I'm going to click here, this surface, and it's going to be highlighted in blue, and I'm going to select the sketch from this small box that pop-ups here. So I'm going to select the sketch, and what I'm going to do here, it is to select this circle, the inner circle, and I'm going to select from the sketch menu, Convert Entities. Okay, and what is going to happen next, it is that a circle was drawn here on this plane, or this sketch that I'm drawing on. Okay, so I'm going to end up with something like this, and I'm going to extrude a little bit this circle. So to extrude, I'm going to Features, Extruded Boss Base, and as you can see, the circle is being extruded outwards. Okay, but I want it to be extruded inwards. So to change the direction, I'm going to go to the Direction 1 section in this menu, and I'm going to change here the direction, reverse direction in this button. Okay, so as you can see, it is already flipped, and I'm going to change the thickness. Remember that the thickness of this cup is 5 millimeters. Okay, so here you have the option to merge the result or not to merge the result. So I'm going to keep it as it is, merge, And this means that the solid body that I'm extruding here, it is going to be merged with the rest of the body of the cup. Okay, so I'm going to click OK. And I'm going to go back to the isometric view. Right? So we need to create later the holder part of this cup. Okay? So in order to do this, I'm going to create a plane that is going through this region. Okay, that is going to be like 55 millimeters apart from the center of the cup. In order to do this, I'm going to go to reference geometry in the features menu. I'm going to select plane, and as a first reference, I'm going to select one of the planes that are available here. Okay, for example, we have front plane, top plane, right plane. I can select, for example, the front plane as a first reference, and what is going to happen here is that it's going to be creating a new plane that is some millimeters apart from the center or from the front plane. In this case, it is already defined as 55 millimeters. That is the amount that we need. But for example, if I type 20, it is going to be created only 20 millimeters away from the front plane. So I'm going to select 55. I'm going to type 55. And that's it. I'm going to click OK. Right? So I want to start drawing some circles in this plane. And to do this, I'm moving to plane 1, and I'm going to select the sketch, right? Later, I'm selecting circle in the sketch menu, and I'm going to be using this reference line in order to create a new circle that is centered in the geometry. Okay? And I'm going to create a second circle here. And we know from the slide that we have a diameter equal to 10 millimeters for every circle. Right? And we know that the distance from the top of the cup to the center of the first circle is 20 millimeters. And the distance between the center of the two circles is 55 millimeters. Okay, so next I'm going to click close dialog. And what I'm going to do next is to extrude the ceramic material that goes from this plane up to the surface of the circle of this cup, So to do this, I'm going to features, extruded boss base, and in direction 1 section, I'm going to select from the list up to surface. And I have to select the surface that I want to use. So I'm going to select this outer surface of the cup body, and you will have a preview of your material here. Okay, so I'm going to click OK, and here we have. So later we have to create a semicircle in order to finish this whole part, and I'm going to click plane here, and I'm going to click hide. Okay, I want to hide this plane. Later, I'm going to have to use another plane, and in this case, I'm going to use the right plane. So select right plane here and click sketch. Later, what I'm going to do next, it is to use a 3-point arc. After I select the 3-point arc here you have three different options: center point arc, tangent arc, and 3-point arc. Okay, so I'm going to select the 3-point arc, and I'm going to position here at the center of this circle, and I'm going to make sure that I highlight this reference point. So I'm going to begin my 3-point arc from here, and I'm going to select the center of the second circle here, and I'm going to make sure that I obtain 180 degrees, more or less, something like that. If you don't obtain the exact value, you can change it here, 180 and 27.5. Okay, there you go. Right? I'm going to click close dialog here, and I'm going to drag or to rotate this geometry in order to visualize what is happening. Okay, what we have is only a line that is connecting these circles. Okay, so what I have to do next is to extrude this geometry here, and I'm going to features, and I'm going to select swept boss base. Okay, so you have to select two different entities. For example, you need to select what is going to be the geometry that the shape that is going to be extruded, and I'm going to say that is this circle here. Okay, and by default it is already selecting the trajectory that this circle is going to be following. Okay, that is this 3-point arc. So I'm going to click OK, and we have finished the cup. Okay, so if you want to visualize what is happening inside this cup, you are going to go to this bar, and I'm going to select section view. Okay, I can change the plane, and you're going to have something like this, right? Okay, so I'm going to deactivate the section view, and what I need to do now it is to close this geometry. When we create a fluid flow simulation analysis, we are going to be requested to define whether we have to perform an internal type of analysis or an external type of analysis. When we have an internal type of analysis, the fluid has to be contained within a closed geometry. Okay, in this case we want to assume that the fluid is always going to be present inside the geometry. So we are going to be performing an internal type of analysis, and we need to contain this fluid inside a closed geometry. And to define the closed geometry, we need to create a leaf. So we are going to flow simulation. Okay, remember that you can activate the flow simulation tab going to SolidWorks add-ins, and here you must find SolidWorks flow simulation complement. Okay, another way in which you can activate the flow simulation complement, it is going to this arrow here and select add-ins, and here you must find in the list the flow simulation complement and activate both checkbox here and click OK. Okay, so now that you have the flow simulation tab, you are going to tools and create leads. Right, so I'm going to get closer to the hollow part, the open boundary, and I'm going to select the surface that is near this orifice. Okay, so there you have a preview of the lead that is going to be created, and I'm going to click OK. So I'm going to activate the section view, and you're going to observe something like this. Okay, And this is going to help us to define that the fluid is going to be contained within this geometry, and that we can perform an internal type of analysis. When you have an external type of analysis, it is similar, for example, when you are analyzing the aerodynamics of a plane or a car or a ball, etc., etc. Okay, so I'm going to deactivate the section view, and I need to save this geometry before anything else, and I'm going to say that this is the top tutorial. Okay, there you go. Okay, now we are ready with the definition of the geometry, and now we want to start by defining the flow simulation model. To do this, we are going to the flow simulation tab, and we are going to select wizard. The wizard is going to guide you through the first steps of the definition of your project, and in the first step you're going to define a name. So I'm going to set it as COP and click next. In the second step, you are going to select the unit system that you want to work with. So I'm going to select SI, that is the default, but I'm going to change only the temperature parameter for Celsius degrees. Okay, and click next. In the third step, you have to select the physical features that you want to consider within your flow simulation model. We're going to consider fluid flow, conduction. We are going to select time dependent because we want to track the change in the temperature of the computational domain or the materials, and we are going to track this during 300 seconds. And the step size is going to be 10 seconds. We're going to consider the gravity, and if you can notice here, you have the preview of the direction of the acceleration of gravity, but we want to change it to the y component or the y axis. I'm going to copy this value, and I'm going to leave this as 0. Okay, so here you have the preview. We are not going to consider rotation, free surface, and in this part, in the second section, we can select whether we have an analysis internal or external. Remember that here the fluid is contained inside the geometry, so it's going to be internal, and I'm going to deactivate this checkbox that says that we want to exclude cavities without conditions. We're going to deactivate it and click next. In the following stage, we need to select what is the fluid that is inside the geometry. So if we click add, by default is going to add water, but if you want to add any other or any different liquid or fluid, you can expand these tabs. Okay, in this section you have to select whether you have a laminar flow, turbulent flow, or laminar and turbulent flow. So I'm going to leave it as default and click next. In the following stage, you have to select the material that you are going to be working with for the solid material, and I'm going to select ceramics and typical aluminum. Next, here if you need to define that you have a heat flux through the walls, you can specify it here. In this case, we're going to assume that we are not losing any heat throughout the walls. Okay, this is an assumption. And next, and finally, in the final stage, we need to select or specify what are the initial temperature and the initial velocity field for this model. In this case, we said that the initial temperature of the solid it is 20 Celsius degrees. We don't expect that the fluid is initially moving, and the initial temperature for the entire model it is going to be 20 Celsius degrees as well. Later we are going to define what is the initial temperature of the fluid. So we can now finish the wizard, and the software is going to determine what is the best computational domain for this model. Okay, so the computational domain, if you go to this node here, you can change the size of this computational domain, but we're going to leave it as default, and we want to hide these lines, okay, because we are not going to need them. So later we need to specify some initial boundary conditions. In this case, we want to specify the initial temperature of the fluid. So I'm going to activate the section view in this bar. Okay. And I'm going to go to conditions here in the flow simulation tab, conditions. I'm going to select initial condition. And I'm going to select these boundaries. This one here, this one here, and this one here. Okay, they are 3 phases, and this represents that I'm involving or surrounding the fluid that is contained inside this cup. So the temperature for the water is going to be 87 Celsius degrees. Okay, and I'm going to click OK. Now we have this. Remember that we have already defined that the initial temperature of the ceramic material, it is 20 Celsius degrees, right? So here we need to define a goal, okay? And the goal is going to help us to retrieve some special information that we want to use in order to plot some parameters. For example, I'm going to add a goal plot, a goal, and I'm going to insert volume goal. Okay, volume goal means that we are going to retrieve an average value for an volume or from a geometrical shape. Okay, I'm going to insert volume goals, and I can select here this volume that represents the ceramic material. I can click here, and we are going to be able to select it as sweep 1. Okay, it is the name that was given by the software. And we are going to select from parameters. I'm going to look for temperature of the solid, and I want to retrieve an average value. Okay, so I'm going to click temperature solid average and click OK. So the software is going to be able to calculate this in time. Okay, so we don't need any boundary condition. The solid material is already defined in the wizard. The fluid subdomains, in this case we only have one fluid and was already defined, so we don't need to define it. The initial condition for the liquid was already defined here, and we can define the mesh. I'm going to double click on global mesh, and we can increase it a little bit or leave it as default. Click OK. So if you want to visualize the mesh, I'm coming back here and show basic mesh. Okay, you can refine it a little bit more if you want. Okay, click OK. And there is another issue that we have to solve here. In this case, we already defined a goal for the temperature of the volume of the cup of the ceramic material. But what happens if we want to retrieve the information about the temperature of the fluid? Okay, so if we click insert volume goal, when I want to select the volume of the fluid, we are not going to be able to select it. It's not going to be available. Okay, because we don't have a physical feature or a physical geometry that represents the volume of the fluid. So what we want to do, or what we have to do, is to draw a physical volume that represents the volume of the fluid. Okay, so we're going to do this in a minute because it is a little bit more tricky or difficult, but we only have to make some arrangements later. Okay, I'm going to cancel here, and I'm going to be able to run this simulation as we have it right now. So I'm going to flow simulation, and I'm going to click run and select new calculation, run. Okay, here we already finished this. I'm going to go to flow simulation. I'm going to click display, and I'm going to select transparency. I'm going to set it to 100%, and here in results, here we are going to retrieve our results. So I'm going to expand results, and I'm going to add a cut plot. Okay, right click on cut plot and click insert. Okay, if you want to change the plane that is going to represent this cut plot, I'm going here in this section, and I'm going to expand this tab and select right plane. Okay, there you go. I'm going to display the contour, and this contour is going to represent the temperature, both the temperature of the solid and the temperature of the fluid. And I'm going to type 100 levels. If I click here, we're going to obtain a preview, and we're going to have something like this, right? This means that we are at 300 seconds, right? So I'm going to click OK. I'm going to change a little bit the illumination. I'm going to flow simulation, display, and I'm going to deactivate lining. Okay, so here in this bar, I'm going to change from 20 Celsius degrees up to 87 because it's the maximum temperature that we expect. Okay, and we're going to observe something like this, but remember that this is a time-dependent study. So we are observing, in this case, the temperature profile or the temperature contours at a time of 300 seconds. Okay? To visualize any other time step, I'm going to results, right-click on results, and we're going to select low time moment. Okay? So I'm coming back to 0 seconds and click OK. So here you can observe that you have an initial temperature of the fluid equal to 87 Celsius degrees and an initial temperature of the ceramic material equal to 20 Celsius degrees. Okay? If you want to visualize any other time step, you're going to results, right click on it, a low time moment, and I want to visualize, for example, 10 seconds. And you're going to observe this. For 20 seconds, there you go. Okay, so how can you generate a animation from this information? So in this case, there is something called Transient Explorer, but in this case we don't have specify how we can generate this Transient Explorer or this animation. Okay, so to do this, we're going to go to input data, right click on it, and select calculation control options. Okay, here you have the conditions for finishing the simulation, and the condition for finishing the simulation is when you already calculated a physical time of 300 seconds, right? But there is another tab here that is called saving. And saving, it tells you that if you want to save the full results, you're going to have to start the stage in order to save every stage at 0 seconds and under a period of 10 seconds, right? but the Transient Explorer has to be activated here, right? Remember, the Transient Explorer is going to show you an animation. I'm going to save it periodically. Start at 0, add iteration 1, and the parameters that you want to save are this one here. Okay, if you want more parameters, you can activate it here. So I'm going to click OK, and you have to run the simulation again, right? So I'm going to click Run, New Calculation. Make sure that you select New Calculation and Run. Okay, solver is finished. Now we are able to go to Results, right click on it, Transient Explorer, and here it is available the cut plot that you already specified. I'm going to right click on cut plot and click Show, right? I'm going to select this view, and I'm going to click Plate here. Okay, if you want to observe it a little bit more smooth, I'm going to type 500. Okay, 200. Okay, there you go. That is something that you can do with Transient Explorer. So I'm coming back to the normal mode, and remember that we define an objective, a goal. I mean, the goal is for the temperature or the average temperature of the solid material. So to retrieve this information, we are going to goal plot. I'm going to insert, and I'm going to select this goal that we already defined, and I want to plot this against the physical time, right? And I'm going to click OK. So I'm going to this node, goal plot. I'm going to right click on it and going to click Show, and here you have this information. This information tells you how the average temperature of the solid material it is changing as we progress in time. And we must be able to obtain a similar plot for the liquid, but we don't have defined the average volume temperature for the liquid. Okay, we're going to do it in a moment. If we come back to the Transient Explorer, I'm going to Results, Transient Explorer, and I'm going to click Play. Okay, we're going to observe how the animation shows you the instant for the value of the temperature of the solid material, right? Okay, I'm going to stop this. I'm coming back to normal mode, and I'm going to hide all of these things. Hide, hide. I'm going to show again the geometry. I'm coming to flow simulation, display, and transparency. Okay. Okay, there you go. So save your work here. If you want, you can save a copy. I'm going to create a new folder, and I'm save it as bit3. Okay. So I'm going to create the volume of fluid that we need in order to track the average temperature of the fluid. So to do this, I'm coming back to here, to the Feature Manager design tree, and I'm going to select this surface here, and I'm going to click Sketch. Okay, so I need to generate a solid body that represents the volume of the fluid. So to do this, I'm going to extrude a circle here, but I just need to generate a circle. So I'm going to select this circle, and I'm going to sketch and convert entities. Okay, so I'm going to Features and Extruded Boss Base. And here I'm going to extrude this. I'm going to try with up to surface in direction 1, up to surface, and I'm going to select this surface. So there we have. And I'm going to deselect here or deactivate merge result, because I don't want this body to be merged with the cup. I just want it to be an independent body. So I'm going to click OK. And we're going to have some messages. I'm going to set yes, and this is telling you that if you want to reset the mesh settings from the flow simulation model, and you're going to have an error here. Click close. Okay, we're going to fix these errors coming back to the flow simulation tab, and we're going here to input data and right click on it and select component control. And in component control, you have available some bodies or elements that are considered within the flow simulation model. In this case, we are considering the sweep one, it is the cup, imported one is the lid, and both extrude 3, it is the volume of fluid, right? But we don't want to consider the volume of fluid as a solid, so I'm going to deactivate it and click OK. Okay, now we only have to fix the initial condition error. So I'm going to delete this, and I'm going to add another initial condition. And I'm going to select some boundaries that we have here. For example, I'm going to select this boundary directly, this boundary, and this boundary. And I'm going to define a temperature of 87 Celsius degrees and click OK. Okay, and now we don't have any error. So we are going to be able to select now in goals, right click on goals, insert volume goals, and now we can directly select the body that represents the volume of fluid, right? So I'm going to right click here, select other, and I'm going to select the one that is called Boss Extrude 3. Okay, this represents the volume of fluid that we generated. Okay, Boss Extrude 3, and I'm going to look for the temperature of the fluid average value and click OK. Okay, now in gold plots, I'm going to insert, and we must be able to select the temperature of the fluid and click OK. I'm going to represent it in terms of physical time and click OK. So for this to be available, we need to run the simulation again. I'm going to flow simulation, run, new calculation, and run. Okay, solver is finished. I'm going to close this, and I'm going to represent this. I'm going to click show and show, right? So you can see how the average temperature of the fluid is decreasing in time and how the average temperature of the solid is increasing in time, right? And we can observe this using the transient explorer. I'm going to have to activate the cut plot, lightning, and play. Okay, so these are the plots that are represented or that I showed in the presentation. Is this one here and this one here. Okay, and if you want to save this information to an Excel, I'm going to double click here in goldplot 1 and export to Excel. Make sure that you are using the physical time, because you have also available the CPU time and the iterations number. So show, export to Excel. And here you have the plots and the raw data, right? I'm going to close all of this, and that's all. Okay, so this is the finish of our tutorial. I expect that is useful for you and that you can apply it in your classes with your students. Okay, so thank you so much, and see you in next tutorial. Thank you.